All right, so the directions here on this slide are to simplify the square root. Okay, so this is review from last week, but with a little something new in it. So square root of 49, okay, well, 49 is a perfect square, so that's just 7. All right, 32, all right, so that is 16 times 2. And so the square root of 16 is 4. So this is just 4 rad 2. And now this is the new piece. Okay, this is impossible. There is no way to think of any number times itself to equal a negative, right? Because a negative times a negative is a positive times a positive is a positive. So this is impossible to do. All right, so what we are going to learn right now is that this is called an imaginary number, or really we call it a complex number. All right, but it does not fit on the real number line. All right, so a lot of people refer to it as imaginary. And so all we have to do to represent this negative, okay, is mathematicians are calling the square root of -1 I, right, which should be easy to remember for imaginary. All right, and so anytime you see a negative inside the square root, all right, we know that we could represent it with an I. So really what this is saying is the square root of -1 times the square, oops, I put an I in there, and do that. Square root of -1 times the square root of 25. And so since the square root of -1 is I and the square root of 25 is just 5, right, we write this as 5I. Right? And the imaginary part, right, that I goes after the real part. So 5I, you don't write it I5. All right, and so now we know if we're doing the quadratic formula and we get a negative inside the square root, we no longer write no real solution. Okay, we're going to write the complex solution by using i's. All right, so everything stays the same. We simplify everything the same, just like we did with the 49 or the 32, but there would just be an I in there. So if there was a -49, right, this would become 7I. If this was -32, right, this would be 4I rad 2. All right, and so everything, right, if anytime there's a negative, right, there's just going to be an I when you're done simplifying the radical. All right, so now just going over it, so skip that. All right, so now you'll be trying this one on your own. Which ones are imaginary? Okay, so this one is, this one is, this one's not because that negative is on the outside, but this one is. All right, now if we want to simplify all these, okay, so just more practice. So 121 is a perfect square, that's 11, so that's just 11I. Okay, 45, all right, that's 9 times 5. So 3 rad 5, but because there's a negative in it, it's 3I rad 5. Again, where are these i's coming from? The negative that's inside, remember that equals the square root of -1. Technically, there's a square root of -1 out here as well, right? Okay, negative square root of 700. So the negative's on the outside. This is 100 times 7. So square root of 100 is 10, so it's just -10 rad 7. Notice there's no I in this problem because there's no negative on the inside. Right? 72 is 36 times 2. Square root of 36 is 6, right? So this would be 6I rad 2, but there's already a 2 out in front, okay? So it's 2 times 6I rad 2, and so that'll just be 12I rad 2. All right, so that is how we are going to handle, okay, when negatives inside the radical. We now have this new type of number. It does not fit on the real number line. We call it imaginary, all right, or complex. These are called complex numbers. All right, here's a video. You can watch this on your own. It's about the quadratic formula. So what is the quadratic formula? All right, so it is negative b plus or minus b squared minus 4ac all over 2a. All right, and this is not some magical formula that was just made up. This was derived by using the completing the square technique that you guys watched in your ed puzzle on Monday. We're not going to spend time using the completing the square technique because this ends up doing the same work. So instead of learning two things, we're just going to focus on one. But the completing the square is very important. It will show up again in future math. So please make sure you watched that video yesterday and took notes on it. All right, so here again, just general overview. Okay, where does the A come from? Where does the B come from? Where does the C come from? So good practice before you do the quadratic formula. Okay, make sure it's in standard form. All right, so there's nothing on the other side of the equal sign. All right, we want it to be equal to 0 every time, so we have the true C, because this is going to help us find the x-intercepts, the roots, the zeros. All right, so question is, which one is correct? All right, so we're looking at this right here, remember, is negative b. All right, so the opposite of b, so the only one that has b as being a positive 5 is right here. All right, then b squared, 4ac, a is 2, c is negative 3, so this is definitely c. All right, so come back here and we pick c. So, okay, same question, but backwards. All right, so we're looking for b is negative 3. So we're looking for a negative 3 on front. So now we got it narrowed down to b or c. All right, they both have the b squared, okay, minus 4ac. So is c positive 8 or c negative 8? So if c is negative 8, it's b, which it is. So this one will be b. All right, all these signs make a big difference when you're plugging the stuff in. I already forgot which one it was. B. Okay, so plugging in is very important. I like how they use parentheses there to do this. Okay, so an example here. It's all worked out over here. I'm going to go ahead and show the work. On here. Maybe I don't have my writing utensils. So I'm going to go ahead and just scroll through. So they plugged everything in. Okay, so negative b, so negative 3 plus or minus b squared. Okay, minus 4ac. Again, notice how they're using parentheses. A is negative 1. Okay, this is real important when you multiply this out that we keep our signs straight. All right, so it's very direct. It's very, just plug everything in. That is step 1. Step 2 now is to go ahead and start to simplify, okay, this expression by following order of operations. All right, so we need to do what's inside the radical, because that's all grouped together. All right, so 3 squared is 9. Right, then negative 4 times negative 1 is positive 4. Positive 4 times negative 2 is negative 8. So it's 9 minus 8. All right, and then we also did the 2 times negative 1 and the negative 1 times 3. So over there we're at right now. Now we have to keep simplifying the inside of the radical. That's going to be 1. So now we're at negative 3 plus or minus the square root of 1 over negative 2. Okay, now can we simplify the square root of 1? We can. That's just 1. All right, and now we can, because this is no longer has a radical on it, we can figure out this is a rational number. We can go ahead and add up the top. All right, negative 3 plus 1 divided by negative 2, and also negative 3 minus 1 divided by negative 2. So you can see here, that's what they did. They rewrote it as 2 different problems, one being plus, one being minus, and then they solved it. Negative 3 plus 1 is negative 2, divided by negative 2 is positive 1. Negative 3 minus 1 is negative 4. Negative 4 divided by negative 2 is positive 2. Right? So the two answers are 1 and 2. Okay, and if you graphed it, right, you can see that the x-intercepts are at 1 and 2. And because it was equal to 0, that's what we're finding are the x-intercepts. Okay, so the graph supports our algebra. All right, so our turn here. Let's do it by hand. All right, so solve using the quadratic formula, show all your work. So in the direction say find the 0. So we're setting this equal to 0 and solving. All right, so again, to use the quadratic formula, it must be equal to something. All right, and before we use the quadratic formula, it has to be set equal to 0. So if this was a number over here other than 0, you would have to subtract it over and get it equal to 0 before using it. All right, so now we know our A is 2, we know our B is negative 7, we know our C is 3. So we just plug everything into the quadratic formula. X equals negative B, so negative negative 7, right, plus or minus the square root of B squared, so negative 7 squared, minus 4 times A, so times 2, times C, which is 3, all over 2A, so 2 times 2. Again, so I am showing everything. I'm sure most of us are probably capable of not writing negative, negative, could have wrote positive 7. Most people could have wrote 49 right away. Okay, I'm just showing everything. This is good practice, okay, because it really helps eliminate mistakes with signs if you see it all first. All right, but so this is positive 7 plus or minus, and then negative 7 squared is positive 49. And 4 times 2 is 8. 8 times 3 is 24, so minus 24 over 4. So it's 49 minus 24 is 25, which is nice because that is a perfect square. All right, and so we get 7 plus or minus 5 over 4. All right, which we're going to break up into two different expressions. So 7 plus 5 over 4 and 7 minus 5 over 4. And then I'll simplify both of these. Okay, so 7 plus 5 is 12. 12 divided by 4 is 3. So one answer is x equals 3. And 7 minus 5 is 2 over 4. Simplifies to 1/2. We always want to simplify all of our answers. My answers for this problem are x equals 3 and x equals 1/2. So the zeros of the function, okay, are 3 and 1/2. All right, so again, show all work, solve the quadratic equation, use the quadratic formula, right? Simplify answers, show all work. Okay, in your homework today, it says show all work. I need to see all your work on your paper. All right, so I'm gonna plug everything in. So I'm gonna make that skinnier so it all fit. So x equals, all right, let me see if I could save some time here. So negative negative 4 is positive 4. Plus or minus the square root of b squared, so negative 4 squared is positive 16 minus 4ac. Okay, this is where it gets a little trouble. I'm going to try to do it in my head. So negative 4 times 5 is negative 20. Negative 20 times negative 15 is positive 300. If you're going to make a mistake, it's usually with this sign right here. Okay. That's over 2a, so 2 times 5 is 10. All right, so we have 4 plus or minus the square root of 316 over 10. All right, so we got to break down 316. All right, so we want to simplify that. So we need to find the largest perfect square factor that goes into it. Okay, so that is 4 times 79, so that's going to be 2 rad 79. So I have x equals 4 plus or minus 2 rad 79 over 10. Right, so now the radical is simplified all the way, but now can I simplify the fraction? All right, and so this, you have to look at the 4, the 2, and the 10. Does anything go into those three numbers? Okay, because you could separate this as 4 over 10 plus or minus 2 rad 79 over 10. It's really two separate fractions, which is written as 1. But we're going to keep it as one fraction. Okay, 2 goes into all of those, so I'm going to divide everything by 2. So I'm going to get 2 plus or minus rad 79 over 5. All right, and now I can leave my answer like this. Again, I could separate it as two different answers, 2 plus rad 79 over 5 and 2 minus rad 79 over 5, but it's just easier to leave it, okay, as 1. The plus or minus implies that it's two different answers. All right. Okay, so now in this one, okay, before I get started, I have to add the 39 over. It's not equal to 0. So I'm going to add 39 first. And when I add 39 to 250, I get 289, which is a perfect square. So I could actually solve this one by factoring, but we will use the quadratic formula because that's what the directions say. I'm going to get some pretty big numbers here with this one. So you're probably going to want a calculator, okay, to help you out with some of these numbers. So x equals negative b plus or minus b squared. All right, so I want to do 34 squared, which is 1,156. Again, I just typed that into my calculator. Minus 4ac, 4 times 1 times 289, which also is 1,156, all over 2a, so all over 2. So this is 0 in here. So 34 plus or minus rad 0 is just 34 over 2, which is 17. Okay, so just one answer in this case. Again, why is it one answer? Because inside the radical is a 0. So there's no such thing as plus or minus 0. It's just 0. We get one answer. Again, if you notice here, I could have factored this as x plus 17 or x minus 17 squared. All right, because 289 is 17 times 17, and 17 plus 17 is 34. All right, so you could have seen that we could have factored it as well. All right, but our answer is x equals 17. Just one solution here with the quadratic formula. And again, I got one solution because the inside of the radical was 0. All right, so speaking of that, we have something called the discriminant, which is what's inside the radical. And so here's just some notes on that. So if the inside of the radical is greater than 0, it's positive. Okay, we get two real solutions. And there's two types of real numbers that we have to worry about, rational or irrational. Okay, irrational means that your answer is going to stay in a radical. Okay, you simplify it and the radical is still there. Or rational, the number inside the radical is a perfect square. All right, so when it's a perfect square inside, you're going to get a rational. When it's not a perfect square, you're going to get irrational. But they're both real, and that's what we care about, is that they're real. All right, we will be able to see them on the graph. They will hit the x-axis. All right, and then when we just saw this one, when the inside was 0, it's one rational root, which means the vertex, okay, is hitting the x-intercept. And then, which we started to look at earlier on, when there's a negative inside, what happens when there's a negative inside the radical? We know that that's imaginary. We're going to call that two complex roots, okay, or two imaginary roots. What's that look like on a graph? It looks like the graph never touches the x-axis. Again, the mathematical word for this is the discriminant. The discriminant is the value underneath the radical in the quadratic formula, the b squared minus 4ac. All right, so if I do this problem right here, all right, so we solve this. Again, let's go ahead and do some of the basic math in our head. So negative b, so negative 10 plus or minus the square root of 10 squared is 100 minus 4ac. Okay, so negative 4 times 11 is negative 44 times 7 is going to be negative. Okay, so 44 times 7. 308. So now over 2 times 11, 22. So I'm going to get a negative inside my radical. So I'm going to have two imaginary or two complex solutions here. So negative 10 plus or minus the square root of negative 208 over 22. All right, so now you got to simplify 208. All right. So we need to find the largest perfect square that goes into 208. And that is 16. So this will simplify to 4i rad 13. 16 times 13 is 208. So I get x equals, okay, the negative 10 stays negative 10 for now, plus or minus, and now I'm just simplifying 208, just like we did for our warm-up. Okay, again, it's 16 times 13, right? So it's 4 rad 13, but there's a negative inside, so it's got to be 4i rad 13 over 22. All right, so I have two complex solutions. I still have to simplify again. Does anything go into the 10, the 4, or the 22? Yes, 2 goes into all those. So negative 5 plus or minus 2i rad 13 over 11. All right, and so that's my complex solution, my two complex solutions, all right, are right there.